Hello, back again, and I want to talk a bit more about this integration of QuickJS, a JavaScript runtime, into a Rust code environment and um, running it in WebAssembly and then running it as a smart contract in on the Near protocol blockchain. So last time I talked about show you how to actually how this Rust program was supposed to look like, how it was integrated with C libraries for QuickJS, and now today I'd like to talk a bit about testing because it's a bit different when you have this QuickJS library and the static libraries. They are compiled for the WebAssembly target. We can actually see that the static library files that we have in the lib folder here, and it's especially this one here which contains the QuickJS. It's compiled for WebAssembly target. It's in another project. It's this project called QuickJS wasm near. And all these other libraries here, they are from Emscripten. And in order to test that, unless we should provide any target any library for different host platforms, which we don't want to do. We actually want to test it with a WebAssembly target. So in order to do that, we have to write the tests a little different. So when it comes to, for example, the near SDK RS for Rust, we cannot use the normal test environment that comes with it because it's not built for the WebAssembly target. So I kind of had to write my own little near testing setup here. And another thing is that you cannot just run it by writing cargo test. You have to also execute the resulting test binary in WebAssembly runtime. So either, for example, Wasmer or wasmtime or wasm3, they should work. And because what you get in the end when trying to compile the test here, it's a WebAssembly binary file. So let's just have a look at actually running it. So, well, I've done it already. It's running this little shell script here. It's compiling and it's running the tests. You can see that it prints the output of the tests just like you would do it when running Rust tests normally, and you also get the standard output here. So what you can see here from this shell script running the test, it's actually calling the cargo test and with a wasm32 target, and without actually running them. So it's just creating this WebAssembly binary, which we then use the WebAssembly runtime, in this case wasmtime, which takes the final WebAssembly target from this output folder. And we also want to have this argument to wasmtime in order to show the output of the test. And let's have a look at the source here. So if we go here and we see the different tests, here we see the smart contract itself, the methods that we want to test, and here we see the configuration for the test setup. So what we do first is to set up the test environment. We need inside here, we have a panic hook just to be able to also capture when it panics, so that we can see the output, see where it actually failed. And if we just try to give a wrong assertion here, we will see that, okay, we get the stack trace, the full stack trace, but we see the assertion failed. So it works as it should. And let's also see what happens inside this test environment setup, which is here. So here we are, in case of near protocol, we are actually mocking these WebAssembly imports, because if we produce this WebAssembly binary, we'll see that if we don't mock these ones, it will have these import statements inside binary. And in order to avoid that, we can just implement it here. So we have them kind of set up with an extern C and no mangle, because we want it to be exactly with these names. So, and by doing that, we can actually implement the methods that near protocol VM will provide to when running these smart contract WebAssembly binaries. So here it's a simple implementation of the getting the signer account ID. I haven't implemented all of the methods here that can be done as we need them, but we have the value return, we have logging to the contract output, so we have some of it here. And reading the registers, that's kind of one of the important things when we want to interact with any kind of value, really, with parameters or storage or whatever. So so that's it. And we also have this simple test environment where we set up this panic hook so that we can just have the output when it panics from the standard error. So that's about it. So to say it, kind of conclude, we cannot use the standard test environment that comes with near Rust SDK, so we have to implement our own here, but it's not that much to be implemented. It depends, of course, on the complexity of the contract, and well, yeah, it's obviously a lot if you have a lot of things going on in there, but you can implement quite a bit of things this way, and to be able to have a test environment that works. And also here, if we go back to GitHub, you can actually see the test runs that have been run on the builds here. Let's just have a look at that. So it's in the GitHub Actions workflow. You can inspect the source for them to see how it works. So you see the unit test run here, and the output as you saw, and also there's an end-to-end test here that deploys the contract on the testnet, builds it first, and then deploys it here. And we are running a small little end-to-end test here for just, well, let's look at the source for it. If we go back to Visual Studio Code again, you can see that there is this end-to-end folder here, and we are running two tests. We are testing just running a custom JavaScript in the contract, and just sending in the script and looking at the results from the logs and the return value, and also trying to submit and store the script on chain. And after that, we will run the script that was stored for that account, as I showed you in the previous video. So I hope you got a bit more understanding about how the test setup for this QuickJS and Rust integration for WebAssembly and Near works. So thank you for watching again.